Good morning, all of you. We'll be starting with the next topic of Unit 1, that is translators. And I'll be today explaining you about the language processing system. We'll be talking about two types of languages, that is your low level language and high level language. And we'll be also talking about translators like compilers, interpreters, and assemblers. Before starting with the topic, let me show you what we are going to study in today's class with the help of a small video.
Translators and the different types of translators. Let us consider two persons trying to communicate with each other. Here one person knows English language and the other person knows Hindi language. If they communicate with each other, it will not be a successful communication since both the guys don't know a common language. In this scenario, the translator comes into picture. The translator will be knowing both the languages and it will help them to have a successful communication in between them. Similarly, if a programmer wants to communicate with the computer, then there should be a translator who can convert the programming language into machine language. A translator is a programming language processor that converts a computer program from one language to another. It takes a program written in source code and converts it into machine code. It discovers and identifies the errors during the translation. There are three different types of translators: assembler, compiler, and interpreter.
So let's continue. As you have understand and you have got a brief idea of what a translator is and what do you mean by a language processing system, now let's do it in detail. The first thing that we'll be starting is language processing system. Every computer understands two types of languages, a low level language and a high level language. So let's talk about what are the characteristics of a low level language. A low level language is something that can be understandable by the machine. That's why it is known as machine oriented. Whenever we write an assembly language program, for one machine, it will only work on that machine and it cannot work on any other machine until and unless both the machines have same kind of processor chip. That's why we call it as machine oriented. So every machine has a different kind of a low level language. You may call it a limitation or you may call it a characteristic of a low level language. Also, when we talk about assembly language statement, every statement basically translates into a one machine code instruction. So therefore, the program that we have is very long and time consuming to create. It takes a lot of time to create a program, to convert an assembly level language into a machine level language. So these are the characteristics of a low level language. After low level language comes your high level language. Now, as the name suggests, high level language is something that is understandable by us. Now, when we say high level languages, the language that we are going to study, that is your C programming, is a high level language. Your Fortran was high level language, Python, Java, all these are high level languages. Now, what do you mean by high level language? Something that we write that is understandable by us. That's your English statement, right? If we write anything in C programming, we're writing it in English, it's understandable to us. If we are writing something in Python, that is understandable by us, right? Every high level language needs to be converted into a low level language, then only the machine will understand that language. So, a high level language is not machine oriented. That means they are portable. That means it is not machine dependent. We need not to make a high level language according to a particular machine. We have translators available that will convert the high level language to a low level language. They are problem oriented. So, a machine level language is problem, not machine oriented, they are problem oriented. Most of the high level languages have structures and facilities, right? So they're based on a particular problem. Now, when we talk about Fortin, as we know, Fortin is developed for using solving mathematical problems. You have MATLAB also there, which is used for solving mathematical problems. Then we have a Pascal, we have Python, we have C, C++, which is developed as a general purpose language. So we have both the categories of a high level language. One is which is specific for one kind of problem, and which are general purpose. Fortran, MATLAB, your R programming, all these are mathematical. They are for solving mathematical problems, right? So when we write a high level language, it usually resembles an English, as I told you a few minutes back. English sentences or mathematical expressions, okay, they are based on these two things. So they're much easier to learn as compared to a machine level language, and much smaller code as compared to a machine level language. The only problem is that we need to convert it to a low level language. So when we are converting a high level language to a low level language, we need a translator. Without translator, we cannot do that. Now, when we talk about computer languages, initially till 1940s, there was machine level language. Machine level languages are very, very, very difficult to understand. Very few people can understand that. Then came your low level languages, right? In 1950s, we have symbolic languages, or we may say that we had other symbolic languages like assembly level language was also there. Then after 1960s came high level languages. Let's talk about a translator. A translator is the one that translates or converts a low level language to a high level language. Mainly there are three types of translators that we have. We have assembler, we have compilers, and we have interpreters. Now let's pick them one by one and let me explain you what an assembler is. So first understand how these languages are translated. A high level language is translated to an assembly level language, and this is done by the compiler. An assembly language is translated to a machine code. This is done by assembler. And then machine code is the one which is understandable by the processor, which is in the form of zeros and ones, right? Which is in the form of zeros and ones, and the processor will execute it. Now, not only the compiler, but assembler also. Sorry, not only the compiler, but interpreter also converts a high level language to an assembly level language. This is a normal flow, or this is a normal way we translate a code. Now let's talk about what assembler does. An assembler is a program that converts an assembly level language into a machine code. And the machine code that we are talking about is zeros and ones. Your assembly level language takes the basic commands and operations from the assembly codes and converts them into binary code that can be recognized by a specific type of processor. So here the problem is the kind of processor. So it becomes a machine dependent language. Assemblers are similar to compilers because they produce an executable code. That is what is the working of a compiler is. However, assemblers are more simple as compared to your compiler. Why? because they convert a low level code, that's the assembly language, into a machine code. We already know that an assembly language is designed for a specific kind of processor. So it requires one-to-one mapping, right? Fine. Now it's very difficult to learn this assembly language. When we talk about assembly language, it is a language which is formed from instructions. For example, if I want to move data from register A to B, we'll write MOV A and then B. That means it is moving data from A to B, right? So they are difficult to remember. That's another difference than your compiled languages. Next comes your compiler. A compiler is a software program that compiles program source code files into an executable program. So this is important. It converts, or let's say it compiles a program or a source code that we have written, right, into an executable program. We need to first compile it, then only we'll be able to execute it. It's again converts a high level language. It's a translator, so it converts a high level language to a low level language. Or we can say it converts every translator because converts one type of language to another type of language. So definitely this also does the same. It converts a high level language to a lower level language. And what assembler was doing? Assembler was converting a low level language to a machine understandable form. Now let's talk about compiler. The compiler takes source code files that are written in high level language, which is like C, Basic, Java, Fortran, Python, MATLAB, R language, right? Compiles the code into a low level language, such as a machine code or an assembly code. The compiler takes the source code files that are written in high level language, such as C, Basic, or Java, and compiles the code into a low level language. Okay, it may be a machine code or it may be a assembly code. Normally it's an assembly code. So this is what is the compiler. Then comes your interpreter. An interpreter converts as compiler a high level language into a low level language, similar to a compiler, but they are different in the way they read the input. Compiler takes the whole program, right, in one go. Read it in input, does the processing, execute the source code, whereas interpreter does not do this thing. It does the same line by line. So normally compiler scans the whole program in one go, but interpreter does it line by line. Compiler will give you all the errors, right, at one time, but interpreter will only give you an error. It will give you the error wherever it will give you wherever the first error that comes, it will give you that error. Because it does it line by line, it checks the program line by line or reads the program line by line. Interpreters are much slower as compared to your compilers. Much slower as compared to your compilers. Right? The example of an interpreter is your Python. Python has an interpreter. So Python is slow as compared to your C and C++. But again, this is not the problem of a Python. This is problem with any interpreted language. Now let's compare all three together. Compiler, interpreter, and assembler. A compiler is the one that converts high-level language to a low-level language. Same is with interpreter. Interpreter also translates high-level language to a low-level language. But when we talk about assembler, it converts the assembly level language into machine level language. A compiler converts the whole program at a time. Interpreter converts the program line by line and will stop wherever it will get the first error. And when we talk about assembler, assembler is the one which converts the language, assembly level language program to a machine level language, right? The examples of compiler are C, C++, Java. The examples of interpreter are Ruby, Perl, Python, and PHP. And assembler uses an assembly language. So there's no name for an assembly language because it's machine dependent. Both interpreter and compilers are portable because they're high level. They're not machine dependent. And your assembler is machine dependent. This is the problem of a low level language, right? So when we take a C program, how does it work? That's important for us to understand. That is important. Why? Because we are going to study C programming. So whatever you are writing is a source code. So you type your source code, the compiler does the compiling because your C++ is a compiler, so it does the compiling. Now what does the compiler do? It converts your program into a binary code. That's your machine level program. Now this binary code takes the input while executing and gives us an output. This input is given by the user and output also is given to the user. This is how a normal C program works. Let's summarize. There are two types of languages that we have. Your low-level languages and high-level languages. Your high-level languages are C, C++, and they are portable. They are not machine dependent. And when we talk about low-level languages, they are assembly-level language and machine code. Both of them are machine dependent. That means if we change the processor, we need to change the code also, right? We need translator to convert a high-level language to a low-level language. There are three main kinds of translators. We have assemblers, we have compilers, and we have interpreters, right? Assembler converts assembly language to low-level language, and compiler and interpreter converts high-level language to a low-level language. The references are given in the slides. If you have any queries, you may contact me on the information given on the screen. That's it for today. Thank you so much.